Taking that internship in a remote mountain lab might not have been the best idea. Pulling that lever with the skull symbol just to see what it did probably wasn't so smart either. But now is not the time for regrets, because you need to get away from these mutant zombies fast. With you are the janitor, the lab assistant, and the old professor. You've gotten a head start, but there's only one way to safety: across an old rope bridge spanning a massive gorge. You can dash across in a minute, while the lab assistant takes 2 minutes. The janitor is a bit slower and needs 5 minutes, and the professor takes a whole 10 minutes, holding onto the ropes every step of the way. By the professor's calculations, the zombies will catch up to you in just over 17 minutes. So you only have that much time to get everyone across and cut the ropes. Unfortunately, the bridge can only hold 2 people at a time. To make matters worse, it's so dark out that you can barely see, and the old lantern you grabbed on your way only illuminates a tiny area. Can you figure out a way to have everyone escape in time? Remember, no more than 2 people can cross the bridge together. Anyone crossing must either hold the lantern or stay right next to it, and any of you can safely wait in the dark on either side of the gorge. Most importantly, everyone must be safely across before the zombies arrive. Otherwise, the first zombie could step on the bridge while people are still on it. Finally, there are no tricks to use here. You can't swing across, use the bridge as a raft, or befriend the zombies. At first, it might seem like no matter what you do, you're just a minute or 2 short of time. But there is a way. The key is to minimize the time wasted by the 2 slowest people by having them cross together. And because you'll need to make a couple of return trips with the lantern, you'll want to have the fastest people available to do so. So, you and the lab assistant quickly run across with the lantern, though you have to slow down a bit to match her pace. After 2 minutes, both of you are across, and you, as the quickest, run back with the lantern. Only 3 minutes have passed. So far, so good. Now comes the hard part. The professor and the janitor take the lantern and cross together. This takes them 10 minutes, since the janitor has to slow down for the old professor, who keeps muttering that he probably shouldn't have given the zombies night vision. By the time they're across, there are only 4 minutes left, and you're still stuck on the wrong side of the bridge. But remember, the lab assistant has been waiting on the other side, and she's the second fastest of the group. So she grabs the lantern from the professor and runs back across to you. Now, with only 2 minutes left, the 2 of you make the final crossing. As you step on the far side of the gorge, you cut the ropes and collapse the bridge behind you, just in You and 9 other individuals have been captured by super intelligent alien overlords. The aliens think humans look quite tasty, but their civilization forbids eating highly logical and cooperative beings. Unfortunately, they're not sure whether you qualify, so they decide to give you all a test. Through its universal translator, the alien guarding you tells you the following. You will be placed in a single file line facing forward in size order, so that each of you can see everyone lined up ahead of you. You will not be able to look behind you or step out of line. Each of you will have either a black or a white hat on your head, assigned randomly, and I won't tell you how many of each color there are. When I say to begin, each of you must guess the color of your hat, starting with the person in the back and moving up the line. And don't even try saying words other than black or white, or signaling some other way, like intonation or volume. You'll all be eaten immediately. If at least 9 of you guess correctly, you'll all be spared.
You have 5 minutes to discuss and come up with a plan, and then I'll line you up, assign your hats, and we'll begin.
Can you think of a strategy guaranteed to save everyone? The key is that the person at the back of the line who can see everyone else's hats can use the words black or white to communicate some coded information. So what meaning can be assigned to those words that will allow everyone else to deduce their hat colors? It can't be the total number of black or white hats. There are more than 2 possible values. But what does have 2 possible values is that number's parity. That is, whether it's odd or even. So the solution is to agree that whoever goes first will, for example, say black if he sees an odd number of black hats, and white if he sees an even number of black hats. Let's see how it would play out if the hats were distributed like this. The tallest captive sees 3 black hats in front of him, so he says black, telling everyone else he sees an odd number of black hats. He gets his own hat color wrong, but that's okay, since you're collectively allowed to have one wrong answer. Prisoner 2 also sees an odd number of black hats, so she knows hers is white and answers correctly. Prisoner 3 sees an even number of black hats, so he knows that his must be one of the black hats the first 2 prisoners saw. Prisoner 4 hears that and knows that she should be looking for an even number of black hats since one was behind her. But she only sees 1, so she deduces that her hat is also black. Prisoners 5 through 9 are each looking for an odd number of black hats, which they see, so they figure out that their hats are white. Now it all comes down to you at the front of the line. If the 9th prisoner saw an odd number of black hats, that can only mean one thing. You'll find that this strategy works for any possible arrangement of the hats. The first prisoner has a 50% chance of giving a wrong answer about his own hat, but the parity information he conveys allows everyone else to guess theirs with absolute certainty. Each begins by expecting to see an odd or even number of hats of the specified color. If what they count doesn't match, that means their own hat is that color. And every time this happens, the next person in line will switch the parity they expect to see. So that's it. You're free to go. It looks like these aliens will have to go home. Your rich, eccentric uncle just passed away, and you and your 99 nasty relatives have been invited to the reading of his will. He wanted to leave all of his money to you, but he knew that if he did, your relatives would pester you forever. So he is banking on the fact that he taught you everything you need to know about riddles. Your uncle left the following note in his will. I have created a puzzle. If all 100 of you answer it together, you will share the money evenly. However, if you are the first to find the pattern and solve the problem without going through all of the legwork, you will get the entire inheritance all to yourself. Good luck! The lawyer takes you and your 99 relatives to a secret room in the mansion that contains 100 lockers, each hiding a single word. He explains, every relative is assigned a number from 1 to 100. Heir 1 will open every locker. Heir 2 will then close every second locker. Heir 3 will change the status of every third locker. Specifically, if it's open, she'll close it, but if it's closed, she'll open it. This pattern will continue until all 100 of you have gone. The words in the lockers that remain open at the end will help you crack the code for the safe. Before Cousin Thaddeus can even start down the line, you step forward and tell the lawyer you know which lockers will remain open. But how? The key is realizing that the number of times a locker is touched is the same as the number of factors in the locker number. For example, in locker number 6, person 1 will open it, person 2 will close it, person 3 will open it, and person 6 will close it. The numbers 1, 2, 3, and 6 are the factors of 6. So when a locker has an even number of factors, it'll remain closed, and when it has an odd number of factors, it'll remain open. Most of the lockers have an even number of factors, which makes sense because factors naturally pair up. In fact, the only lockers that have an odd number of factors are perfect squares, because those have one factor that, when multiplied by itself, equals the number. For locker 9, 1 will open it, 3 will close it, and 9 will open it. 3 times 3 equals 9, but the 3 can only be counted once. Therefore, every locker that is a perfect square will remain open. You know that these 10 lockers are the solution, so you open them immediately and read the words inside. The code is the first 5 lockers touched only twice. You realize that the only lockers touched twice have to be prime numbers, since each only has 2 factors, 1 and itself. So the code is 2, 3, 5, 7, 11. The lawyer brings you to the safe, and you claim your inheritance. Too bad your relatives were always too busy being nasty to each other to pay attention to your eccentric uncle's riddles.